Today we are going to be factoring trinomials, and they'll be in that same familiar form that we've seen before. However, what we're going to end up trying to do is factor out that greatest common factor. So think of that greatest common factor when you're looking at each of these terms. Now, we look at the first one, and we don't have it in descending order. Typically, we write these terms in descending order. This is ascending order, and you could factor it this way. It's just nicer to be consistent. And so when I see something like this, if this were the problem in the textbook, when I write it in my notebook, I would write it in descending order. It just makes it easier for me to factor. The problem will go a lot faster for me. Well, from there, I see there's a common factor between each of these terms. Well, one thing I want to get rid of is that negative sign in front of the x squared term. So I'm going to divide everything by -2. And it's going to make the problem a whole lot easier. In the last lesson we did have one problem where we factored out a negative. We put it on the outside of a big set of parentheses, did some division, and we saw what's left over. And what this does is it makes the problem go a lot faster at the end. You see, now we just have a trinomial that does not have that a term out in front. And so the problem will be a lot easier. So when we go ahead and factor, now we're just looking at two numbers that multiply to make 10. We know x and x make x squared, and there's only a couple options. We have 5 and 2, and we also have 1 and 10. Now we want them to subtract because that last term's negative now. Outside and inside are subtracting to make a -3x. So that tells me it has to be 5 and 2. Now in order to make it a -3x, now watch what happens with our outside terms are 2x, inside are 5x, and if I made the 5 negative, the 2 positive, that's how I could end up getting a -3x. And so it works. -5, +2. So when we write the answer, we want that factored -2 on the outside and x minus 5 and multiplied by an x plus 2 inside some parentheses. And there we have it. Well, same sort of thing. Look for that greatest common factor. So what goes in here? 2 goes into there, all those numbers, but also 4. So look for the biggest number. Pull that 4 on the outside and then rewrite the problem. It makes a 3x squared plus a 7x minus a 6. And that made the problem a whole lot easier because now we've got a prime number as our first term in the trinomial. And so I'm going to go ahead and start with that 3x and x. Now I need numbers that multiply to make 6. So when I do that, I'm thinking of 2 and 3, 3 and 2, 1 and 6, 6 and 1. But I know that the outside and inside terms need to subtract. Subtract to make a 7x. And so when I do that, I think, how can I get that 7? Well, I need a number bigger than 7. See, I'm going to multiply the 3x by the 3. That makes 9x. That's bigger than 7. 2 and x make 2x, and I can get those to subtract to make that 7x if I make 9 positive and 2 negative. And there it is. So we go ahead and rewrite our answer, and again, make sure you have that 4 on the outside so that if you did multiply it back out, it would equal the same trinomial we started with. So let's take a look at the next problem. And here we have another common factor. Look at each of those terms. What goes in there? Well, 3 does. You could take out a 3 and it'll make the problem a whole lot easier. Do the division, you got 2x squared minus an 11x and a plus 5. So we've got a great problem here because we've got two prime numbers. Now, it looks like a tough problem, but look at what we know. We know a plus sign on the last digit's term there means that we're going to end up adding the outer and inner terms, and we want to make a -11. So what that tells us is that when we draw our two sets of parentheses, we're going to have minus signs in between the first and last terms in those binomials. We also know that the only numbers that make 2x squared are 2x and x, and we only have a couple options to multiply to make 5. 5 and 1 and 1 and 5. But we want those numbers to add to make 11, so that means we need smaller numbers than 11. So 2 times 5 makes 10, which is smaller than 11, and 1 and x make an x. And so let's check it out. We've got a -10x, we've got a -1x, and those numbers will end up adding to make -11x. So there's our answer. We've got 3 times by 2x minus 1, and we've got an x minus 5. So let's move on to the next problem. And this one here, we've got a 6x squared plus 4x minus 10. So the first thing I'm going to end up doing is taking out that common factor. And what is that common factor? Well, 2. They're all even numbers. It makes the problem a whole lot easier if you see that common factor and you take it out in the first place. And now we've got a great problem because we've got prime numbers here and here. So there's not a whole lot of options. So we go ahead and draw our 2 sets of parentheses. Make sure you put that common factor on the outside. And we look at that last digit sign. It's negative, so when we're thinking of the numbers to put in place the first and last terms in each of the binomials, we're thinking of subtracting the outer terms and inner terms to make a 2x. So we start with 3x and x, and now we want numbers that when we multiply, we don't get too big because they only need to be 2 apart. So if we try the 5 here and the 1 here, we end up with a 3x for the outside terms, 5x for the inside, and those will end up subtracting to make 2x. So it does end up working out. Now, in order to get a positive 2, I need to make sure I have more positives than negatives. So plus 5 and a negative 1 to make a negative 3x. And there's our answer. So we just write that in our answer box, but don't forget to put that 2 on the outside of the parenthesis. So let's take a look at the next one here. Here we end up having a negative x squared term. So let's go ahead and take out not only the common factor other than negative 1, but let's take out a negative 5. And see then, because 5 goes into each of these terms, and it makes that first term positive. And it's a whole lot easier since we're used to factoring with that first term as a positive. So we've got to draw a big set of parentheses and do the division. We've got a 4x squared minus a 5x plus a 1. Now the problem's a whole lot easier. And what made it easier? Well, it's because of this term right here. It's a prime number. Well, it's just a 1, and so the only numbers that make 1 are 1 and 1. So we end up having outside terms and inside terms adding together to equal a negative 5x. So we go ahead and try some different numbers here. Make sure, again, we're putting negative 5 on the outside. And we'll end up, now I think I'm going to leave this as 4x and x. And the reason is I'm going to try the 1 and the 1 first. And again, if 4x and x don't work out, then I'll do 2x and 2x. But I think this might work out because I know the signs both have to be negative. And you see a 4 and a 1 end up making 4. Negative 4x, that is, because I multiplied by a negative 1. Here I have a negative 1x, and I can get those to add to make negative 5x. So it works. So we can go ahead and write down our answer there. Negative 5 times by a 4x minus 1 and an x minus 1. Well, looking at the next problem, another common factor. What goes into all these numbers? Here we have 30, 24, 54. Well, I see a big number. I see 2, I see 3, and if 2 and 3 go into the numbers, then 6 goes into them as well. And so we can go ahead and take out that common factor of 6, do the division. We've got a 5x squared minus a 4x and a minus 9. And so the problem's still tough, but we have a prime number right here, so it makes it a whole lot easier. We've got a negative 9. Tells us that the outside and inside terms are going to end up subtracting, not adding. So let's fix that. So we have an outer minus the inner is going to end up equaling a negative 4x. We don't want to get those numbers too far apart. And so when we go ahead and write down our problem here, we put the 6 on the outside. We can start with 5x and x. Those numbers multiply to make that 5x squared. Now numbers that multiply to make 9. Well, I think I need to multiply it by a 9 and a 1 first. And the reason is that if I did a 3 and a 3, 3 times 5 makes 15. That's kind of big compared to 4, so I didn't want it to get too big. So we'll try this first. If this doesn't work, the 9 and the 1, we can always try 1 and 9. We've also got 3 and 3, so those are different options. So we've got 5x for outside, inside make a 9x, and when I subtract those, hey, lo and behold, I end up with a 4x. Now, I want a negative 4x, so that means I need to have the 9 be negative, the 5 end up being positive. So I put the plus sign here, the minus sign here, and we've got our answers. So make sure you put that 6 on the outside. We got 5x minus 9 as one of the factors, and the other factor was an x plus 1. And so there are some answers to some lesson problems. Good luck on your problems tonight.